Hi, I'm Bryson Barrett, and I'm here with the Prosper News Network. We're here to talk about light. Light as a particle or as a wave. Is it both? Is it neither? I don't know. We're going to cut some quick interviews about what people think about that subject matter and maybe get a little background information about the subject.
Excuse me, sir. I was wondering if you could tell me, is light a particle or a wave? Do you know?
I'd say it's a particle.
A particle? Mm-hmm. All right. Sounds good to me, sir. Thank you.
All right. You're welcome.
Sir, can you tell me whether you think light is a wave or a particle?
I would say light is a wave
And why do you think that?
because of the double slit light experiment.
Oh, thank you. That's very interesting. Thank you, sir.
No problem.
Sir.
Yes.
Can you explain the double slit experiment?
Well, it's Young's experiment where light passed through two slits, created an interference pattern, proving that light is a wave.
That's awesome. Great information. Thank you.
Sir, do you like light is a wave or a particle?
Light is definitely a particle because Albert Einstein's photoelectric effect, in which he shone colored light onto a metal surface and watched electrons bounce off. He caught those electrons and proved that light is in fact a particle.
Sir,
Yes.
do you think light is a particle or a wave?
I think that light is both a particle and a wave, judged by all the experiments that combine together to prove both sides. There's been some for wave, there's been some for a particle, and we're just proving both sides, so light's both.
All right, thank you.
You're welcome.
Well, those were some interesting people. But we're here to talk about the real point. Thomas Young and his double slit experiment, in which he was able to prove that light is in fact a wave. Now, back in Young's time, he didn't have much of a light source, except for the sun. By using a series of curtains, he was able to open one just wide enough to let a few beams of light through. Now, by using a couple of mirrors, he was able to reflect the light around the room, and by cutting it off here and there, he was able to produce one beam of light. Now, he then set three mediums up, two bigger ones on each side and the smaller one in the middle. Now, that created two slits on each side of the smaller one, which made two waves of light radiate from it. Those two waves, while cresting and troughing at the same time, created an interference pattern on the screen that was behind the slits. Now, as they moved out, they got dimmer due to the fact of constructive and destructive interference of the waves. So, in result, there were two outcomes of this experiment. The outcome that we just found, with the interference pattern of the wave itself, or the outcome of a particle, in which case only two lines would be created. So, the outcome of this experiment proves that light is in fact a wave. Young's theory of light being a wave held true until Albert Einstein came along. Now, with Albert Einstein, he used the photoelectric effect to prove that light was a particle. Now, he used this effect by taking colored light and shining it on a metal surface. Now, different metal surfaces required different colored lights. It just depended on the surface. So, he used a machine that allowed him to catch the electrons, per se, as they flew off this metal surface. Now, after the colored light was shown on it, electrons would fire off, and they would be detected by the surface, and he was able to know when they were fired off and how many of them there were. Now, he found this strange, because the higher the intensity of light that he used, it did not cause a higher intensity of electrons. It, in fact, caused the electrons themselves to multiply, which was very different from the common thought. Now, Einstein came up with a theory, and here it is. He said that light in itself is a particle, or a photon, and photons flow to make a wave. So through this process, with electrons flying off, this was only allowed to occur if light was in fact a particle, in which he proved. Now that we've assessed the wave-particle duality of light, we can move on to more than just the two scientists. Now, Einstein and Young had their theories, but there were plenty of other scientists trying to prove their point. We had Bohr, for instance, whose theories of atoms proved Einstein's law. Made it a known fact for most people, even though some decided not to believe in it. Now, we also had Planck, who moved some things out of the way for Einstein when he came along with his experiment. Now, what Planck did is he discovered black-body radiation, which was a theory that all objects glow even when they're not hot. Now, when they tried to measure this, they came upon the ultraviolet catastrophe, which was a fact that when they viewed these objects from infrared and up into ultraviolet and past, the intensity just kept going up and up and up, which was quite impossible because that would mean energy is infinite, which is clearly not the truth. And Planck also discovered that light only emits itself in small bursts. Now, we also had Fresnel, who proved that light has short wavelengths. And he also proved light interference mathematically. Now, for final, we had the Compton effect, which showed how when a photon collided with an electron, the transfer of energy and momentum went into that electron. Now, when the light was shown on it, this photon would collide, and the evidence was all there. It was true. This even furthered the hypothesis of light being a particle. So, with all of these scientists, there were plenty of theories here and there, but the two theories that still remain is light is either a particle or a wave, or both. Einstein and Young are very different people. They lived about 100 years apart. Young, well, he didn't have the technology or the progressive ideas in his time as Einstein did. So, when Young conducted his experiment, it was a little harder for him to get a contained result. Nevertheless, he still had his theory, and so did Einstein. So, in conclusion, light is both a wave and a particle. Now, through Young's double-slit experiment, he was able to prove that by an interference pattern, which was shown on the screen when he performed his experiment, that light is truly a wave. When Einstein performed his photoelectric effect, he proved that light was also a particle, coming from the fact that when he shone colored light, different frequencies of light, rather, on different materials of metal, it would cause electrons to bounce off. Now, this proved that light was truly, in fact, a particle because that would not be capable by a wave. Both theories must be true and accepted by our society, and even though some people do not accept that fact, it is true and known. Well, that's all we have for tonight. I'm Bryson Barrett, and this is the Prosper News Network.